Good morning, everyone. In this lecture, we are going to discuss conversion of regular languages, or you can say conversion of regular language grammar into an automata. So, I have already mentioned the steps which we need to follow in order to convert a regular grammar into an automata. So, let's look at and we will solve few questions. So, you'll be comfortable by the end of this lecture in this particular conversion. So, in the very first step, we need to start like the starting symbol. We need to give the starting symbol name to a particular state. So initial state of the automata will become the starting symbol or a state which is named with the starting symbol. Then final state is named as, let's say, epsilon, and we can construct an equivalent epsilon NFA if we want to construct. Let's take an example and then you do understand that what exactly these steps means. So if this is the grammar and if we want to construct equivalent finite state machine or finite state automata, the very first step is that if S is the starting symbol, create an initial state with that name. So S is the initial state of the automata. Now from S, if we traverse A, we again coming to S only. So there is a loop. By traversing A, we are coming back. Similarly, if from S state, if we take B input, again we are coming to S. So that means there is a loop for A and B both from initial state S. But in case we get A or we get B, the string will be generated. That means it will lead us to a final state, and final state we are naming as epsilon kind of a state, as it is mentioned in this particular third rule. Second rule, final state is named as epsilon. So once we are getting either A or B, we are reaching to the final state. So here we can mention either A or B, right? And this is your final one. So this is the given automata. This is the automata for the given grammar. Now if you want to convert this into the automata, again the similar thing is given. So let's say S is the initial state. Now from S there is another state A. So let's say there is A state. Now from S, when a small a is coming, there is a transition from S to state A. So when A is coming, there is a transition. Now on A, there is a loop for A as well as for B, because from A, we are reaching to A again. Similarly, so you can understand there is a loop by traversing A or either B. And this A is leading us to the final state also. So we can say if there is a final state, like I'm making final state like the epsilon kind of state, either we are getting A or B, we are reaching to the final state, right? So this is the equivalent finite state automata for this given grammar. Let's solve few more examples. So let's say this is one of the grammar. Now if you want to construct the automata for this, A is the starting symbol of the grammar, let's say. So we create an initial state with that name A. Now from A, if AB is coming, you are reaching to A. So that means, because in a single go there can be only one terminal can occur. So we can create, let's say there is another state, some X state or B state, whatever you want to create. So let's say I'm creating some intermediate state B. So what is happening here? From A, when let's say 0 is coming, okay, so when let's say A is coming, and from B, so AB actually we need to maintain. So from A when A is coming, and from B when B is coming, we are again reaching to A only. Okay. So by traversing A, we are reaching some intermediate state, and from that state when B is coming, we are reaching to A. So I hope you can understand there is an indirect kind of loop. And from A, we can reach the final state when A is coming. So let's say a final state is epsilon state. when we can traverse from A by getting input small a, right? Now this fourth grammar, if you want to convert this into the finite state automata, the initial state we need to set as A, because A is the initial state of the grammar, or starting state of the grammar, starting symbol of the grammar. Now from A, we are reaching to B state by traversing either A or B. So either A is coming or B is coming, we are reaching to the same state, that is B. So you can say either A or B, that means A comma B. Now from B, there are loops for A as well as B, so I can apply loop. When you are traversing either A or B, you are reaching to same state B. And from B, you can reach the final state. So if I write the final state like this, from B, we can reach the final state, right? So either A or B, the final state will reach here, right? We will reach on to the final state. So I hope these examples and this description will help you to convert a given regular grammar into the automata. So I'm closing this session. Thank you everybody for connecting. See you in the next class.